All right, guys, today we're going to be focusing on 1.1e, which is building off of the idea of solving multi-step equations. So it says here, 1.1e class activity, solving multi-step linear equations, distribute and combine like terms. So distribute, that's going to be a very big word in this chapter. And the word distribute really means to multiply, right? And we're going to be talking about that through the school year. They also want you to combine those like terms. So like I said in the other videos, we're going to go ahead and cross out this tile stuff. If you would like for me to show you how the tiles work, we certainly can do that, but I want to start going ahead and using these action steps right away. So distribute, we're going to multiply 3 times x and 3 times 1. Well, 3 times x is going to give me that 3x plus 3 equals 12. Now I can go ahead and start solving, drawing my railroad tracks. My goal is to get the variable by itself, and in order to get this x by itself, I need to take everything else away on that side of the equation. So I'm going to subtract 3 on both sides. Well, 12 minus 3 gives me 9, so I have 3x equals 9. Divide both sides by 3, x equals 3. Now on your test, they might ask you to verify. So by verifying, that means I'm just plugging that 3 in x to prove that it works. So if x is 3, 3 plus 1 is 4. 3 times 4 is 12. So yes, it works. Okay, we're not going to model, but we are going to solve down below here. So go ahead and do these with me. Number 2, we're going to distribute. So 2 times x gives me 2x. 2 times 5 gives me 10. So I get 2x plus 10 equals 14. I want to get x by itself. So I'm going to stay nice and organized and subtract 10 on both sides. I get 2x equals 4. Divide both sides by 2. And x is 2. I could plug that back in. 2 plus 5 is 7. 7 times 2 is 14. Yes, that is correct. Let's take a look at number 3. A couple steps. The first thing we need to do is distribute again. So 2 times 3x is 6x. 2 times 1 is 2. I'm going to bring down that minus 2x equals 10. Question, is there anything that can be combined in here? Yes, we have to combine our like terms first. So I have negative 2x and 6x. When I combine those, I get 4x plus 2 equals 10. Same steps as before. I'm going to subtract 2, both sides. I'm left with 4x equals 8. So x has to equal 2 because we divide both sides by 4. Circle your answer and verify. Okay, number 4 looks different, but I promise you it's not. It's the same idea. They just flipped it because of the commutative property. So if I draw on my railroad tracks, my first step is to distribute. 3 times x is 3x. 3 times negative 2 is negative 6. Bring down that equal sign and that negative 12. Now, my goal is to get x by itself. So a lot of 8th graders want to move this. We're not moving anything right now, okay? X is going to stay on this right-hand side. So I'm going to do the opposite to this negative 6 to bring that over. So I'm going to add 6 and add 6. I'm left with negative 6 equals 3x. Now I can divide both sides by 3, and I get x is negative 2 because a negative divided by a positive is a negative. All right, same steps. We're going to go ahead and skip number 5. So let's go down to number 6. It says solve the following equations without the use of tiles. So same idea here, guys. Start by distributing. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2 equals 8. Be careful with that negative sign out front. A lot of people just want to multiply the 2, but don't forget it's a negative 2. Okay, so then you add 2 both sides. You get negative 2x is 10. Divide both sides by negative 2, so x has to equal negative 5. All right, I want you guys to try number 7 on your own. I'm going to hop it on 8. So if you look at this, we need to start by distributing, right? So I'm going to distribute that 2 to the 3a and that 2 to the negative 1. So 2 times 3a is going to give me 6a. 2 times negative 1 is negative 2. And I can't forget to bring down this 5. So now I have 5 plus 6a minus 2 equals 15. First question I ask myself, are there any like terms? Yes, let's combine those like terms. I have a 5 and a 2. When I combine 5 minus 2, I get 3. So I'm going to bring down my 6a plus 3 is equal to 15. Now what? Subtract 3 sides. We get 6a equals 12. Divide both sides by 6, so a has to equal 2. All right, let's take a look at 9. I'm going to start you guys on this one. So a lot of people freak out with the fractions in this, but here's my question. What is a half of 2? Well, 1/2 of 2 is 1, so that's just going to be 1t. Plus, what's 1/2 times 4? Or what is a half of 4? 2. All right, I want you guys to finish that one on your own as well. And we're going to scoot on down to these. Okay, it says, part of the story that matches the expressions and equations shown on the left has been written for you. Finish the story, solve the equation, and determine how much time Theo spends training in each sport. So it says the minutes that he spends swimming is X. The minutes he spent running is 2X. So that must mean he spends 2 times more running than swimming. And he must really like biking because he bikes for 30 minutes more than he does swimming. So it says Theo is training for a triathlon. He runs twice as long as he swims, okay, which makes sense. He bikes, well, he bikes 30 minutes. I'm going to write it down. 30 minutes longer than running. He swims 3 times a week, runs 4 times a week, and bikes. Well, let's think about this. In this equation, it says he runs 3 times a week. Sorry, swims 3 times a week. Where do we see that he swims 3 times a week in this equation here? Well, yeah, that's 3, right? He swims 3 times a week. So 3x would represent his 3 times a week. It says he runs 4 times a week. Well, where do we see in the equation 4 times a week? Yeah, well, there's my 4 right here, right? Why are they multiplying it by 2x? Oh, that's right, because running was 2x. So they say, hey, he does that 4 times. So they multiply that by 4. How long do you think he bikes for, based on this equation? How long do you think he bikes for? Yeah, twice. Where do I see that? Right here. He bikes 2 times. He spends a total of 510 minutes per week training. How many minutes does he spend on each exercise? Okay, well, we just need to solve this. So do it with me. We have 3x plus 4 times 2x plus 2 times 2x plus 30. I'm just rewriting this equation equals 510. Let's solve. We need to distribute. So I have 3x plus 4 times 2x would give me 8x. Plus, I need to distribute here. 2 times 2x is 4x. 2 times 30 is 60. It's 510. Combine those like terms. I have a lot of stuff with x's, right? We've got 8, 12, 15. So we have 15x plus 60 equals 510. I'm going to subtract 60 on both sides. 510 minus 60 gives me 450. So I get 15x equals 450. Divide both sides by 15. X is 30. Wait, what does this mean? What did x represent up above again? Up here, x was the time he spent swimming. So minutes swimming, he spent 30 minutes swimming. Well, he spends twice as much running. So all I need to do, guys, is go up to running and say, okay, well, 2 times 30 is 60. How many minutes did he spend biking? Well, 60 plus 30, when I come back up here to my equation, 60 plus 30 is going to give me 90. Now, you might say, Ms. Widerski, something's wrong with that. Yeah, something is wrong, because when I add those together, they don't total to 510, right? If I add 90 plus 60 plus 30. Okay, what do you think I did wrong? Yeah, we have to go back now and say, okay, well, he did this 3 times. So 30 times 3, that means he did that for 90 minutes. Here, he did it 4 times. So 60 times 4 is 240. And he spent 2 times on the bike, right? So 90 times 2 is 180. So now if I add those together, 180 plus 240 plus 90, you're going to get 510 minutes. Okay? Let's see here. It says, write a story that matches the expression of the equation below. Then solve the equation to determine how much they had on each ride. All right, so story. We are at, let's just say, Swedish Days. We're at Swedish Days in Geneva, okay? You can ride a pony for $B. What do you think the cost? So there's my B. What's the cost to ride a Ferris wheel compared to a pony? Yeah, Ferris wheel costs half of what a pony ride costs. Okay, now what about bungee jumping? 2B plus 5. Well, what did B represent in this situation? Oh, a pony ride. So it's double what a pony ride is plus how much money? Yeah, plus 5. So bungee jump costs double a pony ride plus $5. Take a look at this. How many times do you go on the pony ride? Yeah, 3. I rode 3 ponies. Okay, how many times did you go on the Ferris wheel? 4 times on wheel. What does this represent here? Well, a lot of you are saying bungee jumping. How many times did they bungee jump? Just once. And 1 bungee jump. My total is $33. So what I want you guys to do is to solve this equation. What is half of 4? All right, well, we have 3b, we're bringing it down, plus what's what half 4, or 4 times 1/2? 2b, plus 2b plus 5 equals 33. Go ahead and solve for b for me. All right, so that's here, here, and here. We're going to continue working on this in class and in the next couple days, okay? Send me an email if you need me. Good job.